0 is a saddle point. The second point 1 1, second critical point 1 1 is a local minimum. Similarly, if we take for the third critical point -1 -1, and if we find the value of d at the point -1 -1, d -1 -1 is equal to 128, which is equal to d11 greater than 0, but and fxx -1 is also is equal to 12 is greater than 0. So f -1 -1 is also equal to -1 and is also a local minimum point. So we can say one good thing from this example that the function have more than one local minimum or maximum values, as we saw for the point 1 1 and the -1 -1, the function have a local minimum values, and the 0 0 is a saddle point. Okay, so this is a very useful example to understand our second derivative test for the local maximum and local minimum. The graph of that function we can see here. So look at the graph, which is quite, from which we can easily understand the result. Okay, let us look at another example. For this example, fxy is equal to 10x square y minus 5x square minus 4y square minus x raised to 4 minus 2y raised to 4. We need to find the highest point on the graph of f. For first thing is very easy. Fx is equal to partial derivative of f with respect to x is equal to 20xy minus 10x minus 4x cube, and partial derivative of y with partial derivative of f with respect to y is equal to 10x square minus 8y minus 8y cube. To find the critical point, we will take is both are equal to 0. So 2x into 10y minus 5 minus 2x square is equal to 0, and 5x square minus 4y minus 4y cube is equal to 0. And from equation number 4 we see that either x is equal to 0 or 10y minus 5 minus 2x square is equal to 0. From here the equation 2x into 10y minus 5 minus 2x square is equal, so x is equal to 0 or 10y minus 5 minus 2x square is equal to 0. In the first case, that means if x is equal to 0, then equation number 5 becomes minus 4y into 1 plus y square is equal to 0. So y is equal to 0, and we have the critical point 0 0. In first case, we will get the critical point 0 0 by taking x is equal to 0, we will get y is equal to 0, so the critical point is 0 0. Okay, in the second case, that means 10y minus 5 minus 2x square is equal to 0. We get x square is equal to 5y minus 2.5. Putting this in equation number 5, we will get the equation 25y minus 12.5 minus 4y minus 4y cube is equal to 0. And so we need to solve this cubic equation. 4y cube minus 21y plus 12.5 is equal to 0. This example is numerically just a lengthy example, but it is very easy to understand in which way we are going to find the local maximum and minimum. Using a graphing calculator or computer to graph the function gy is equal to 4y cube minus 21y plus 12.5, we see that equation number 7 has 3 real roots. So this is the graphical method to solve this equation. If you want to solve this equation using any other method, you can solve it, but this method is quite easy and easy to understand that at which this equation which are the solution of this equation. Okay, from this graph we can say that solution of this equation is y is approximately equal to minus 2.5452, and or second one is y is approximately equal to 0.6468, and y is approximately equal to 1.8984. Alternatively, we could have used Newton's method or root finder to locate this root. As I told you that we can also use another method to find the values of y. This is quite easy method to find the values of y. So after all, now x is equal to plus or minus 5y minus 2.5 in root. So if y is approximately equal to minus 2.5452, x has not corresponding values, real values. Okay, we cannot find the real values with respect to y. And if y is equal to approximately equal to 0.6468, at that time x is equal to plus or minus 0.8567, and in the same way, if y is equal to 1.8984, x is equal to 2.6442. So after all, we will get this kind of critical points after all this long process. So we have 5 critical points which are analyzed in the chart. First is 0, 0. Second one is 2.64 and 1.90, minus 2.64 and 1.90, 0.axis and 0.65, minus 0.axis and 0.65. And at all this point, if we use the second derivative test, the chart is ready here, that value of the function is 0 for the 0, 0, fxx is equal to minus 10 and d is equal to 80. That means d is greater than 0 and fxx is less than 0. That means the case number B, that the function is local maximum, right? And for the second, both points plus or minus 2.64 and 1.90, the value of d is greater than 0 and fxx is less than 0, and the value of f is 8.50. That means here these 2 points, at these 2 points function also have the maximum. That means the function have three local maximum. One is 0, 0, second is 2.60 and 1.90, second is third is minus 2.64 and 1.90, and it is clear that 0.86 and 0.65 where d is less than 0, minus 187.64. That means these 2 points, 0.86 and 0.65 is a saddle point, and minus 0.86 and 0.65 is a saddle point. So this is the lengthy example to with 5 critical points, and there is 3 local maximums and 2 saddle points over there. Okay, so these figures gives 2 views of the graph of f, which we have discussed in the last example. So just look at the graph. Just look at the graph where the function is maximum, function have critical point. Okay, so this is very easier way to understand where the function is maximum, where and where which point is the saddle point. Okay, right. This can also be seen from the expression for f of xy. The dominant terms are minus x raised to 4 minus 2y raised to 4 when mod x and mod y are large. Okay, this is just information about the last example, that f of plus or minus 2.64 and 1.90, 8.50, that is the highest point on the graph of fr, plus or minus 2.60, 8.90 and 8.50, where the function is maximum. This is the another example for the maximum minimum values. Here we need to find the distance, which is shortest. That means we need to find the minimum value of this distance for the plane x plus 2y is equal to 0, which is at the point shortest distance from the point 1 0 minus 2. From the distance formula, d is equal to into x minus 1 whole square plus y square plus z plus 2 whole square. We will continue with this example after sort of time, and we will continue this maximum minimum example, and then we will discuss about the Lagrange multiplier and the Taylor series and etc. Okay, so we will meet after 5 or 10 minutes. Okay, thank you very much. Thank you.